the difference between a relation and a function. Now, we had previously learned that a relation is a pairing of inputs and outputs. And we saw that the x values are the inputs and the y values are the outputs. So in other words, it takes one number and pairs it with another. So if we look at 1 comma 2, 1 is paired with 2, and the x coordinate is 1, the y coordinate is 2. Okay, so now we're going to discuss what these values, how we can group these values as a whole. So we are going to talk about the domain and range. This will help us understand relations and functions. So we have right now a set of ordered pairs, and we're going to take each element of the domain, which will be all of the inputs or the x values, and put them in a list. So the domain, we put them in a list in order from least to greatest. So we have -6, comma, -2, 1, and 3. Again, those were all of our x coordinates. Those are all the elements of the domain. Then I'll change colors. And let's talk about the range. This will be all the y coordinates. Well, we have 2, 5, 0, and 4. And we're going to put them in order from least to greatest again. So it's 0, 2, 4, and 5. All right. And we call each number in the domain or the range an element. An element is an individual member of the domain or range. So, -6 is an element of the domain, or let's say 4 is an element of the range. So the domain is just a list of all the x coordinates, or all the elements that are x coordinates, and the range is the list of all the y coordinates. All right, so that's domain and range. Now let's try finding the domain and range for these other two examples, for letter B and C. So for B, the domain we're going to see, we see a -3, a 2, a 3, and a 2. Okay, this time there's a repeated value. So let's just start putting things in order. -3, comma, 2 is next. And does it make sense to write the 2 twice? Well, no, we don't need to do that. That's making more work than is necessary. So we just write it once. And we put a 3. All right, that's the domain. The range in this case will be, again, the y coordinates. 6, 5, 1, 4. So let's put that in order. That'll be 1, 4, 5, and 6. And again, we see that we have elements of the domain, these numbers in purple, and elements of the range, these numbers in pink. We can also find domain and range by looking at a coordinate plot. So let's go over here to this graph on the right. D for domain, squiggly bracket. And this time, we're going to see wherever there's an x coordinate that has a dot graphed above it or below it, we will write that as an element of the domain. So 1, 2, 3, 4, 5, and 6 are all elements of the domain. These are all paired with some number in the range, and then we placed a dot where that pairing happens. So the range in this case will be wherever the outputs are, and we can start down here at the bottom. So -1 has an output, 0, 1, 2, 3, and all the way up at 6. All right. So the way we get these coordinate pairs is we take one of the elements of the domain, let's say 1, and we connect it with, in this case, it's 1, 3, so it was paired with the 3. That's how we got our coordinate pairs. All right. Or we could do the reverse. We could label all our coordinate pairs. So 2, 1, 3, -1, 4, 2, 5, 0, and 6, 6. And we can see again the pairing of all the domain elements with the range elements. And we could take all the x's and put them into our list like we already did. And look at all the y's and put them in our list like we already did. So that's the relationship between the domain and the range. Okay, so these are relations. They're just simply pairings of one number with another number. All right, well, let's look at functions. Functions are a special type of relation. And here we go. A function is a specific type of relation in which each element of the domain corresponds with exactly one element in the range. The x values cannot repeat, should be a little more specific, with different y values. So what that means is we could have 1, 2, that would just jump up 4, 5, and let's say 6, 9. All right, that is a pairing where each element of the domain, the x's, does not repeat, and they all have a different output. So that would be a function. On the other hand, if we had something like 1, 2, 1, 4, and let's say 2, 5, well, here's a problem. We have the same element of the domain is being repeated, and it has a different output. So this would not be a function. All right, it does not matter that we have a 2 here and a 2 here. Those are just completely different things. One is an element of the range, one is an element of the domain. All right. So here's what we're going to want to figure out is in these pairings of numbers, which of them is simply a relation and which of them is a function? Well, there are two ways to check. If any element of the domain, the x value, repeats with a different y value, then it is not a function. Or we could use the vertical line test on a graph. A vertical line test goes with graphs to determine if anything is repeating. So if a vertical line, let's make a little mini graph down here. And let's say our graph goes like that, it's a line. So the vertical line test means we draw a vertical line at any given point on the graph, and as long as that vertical line only intersects at one little point, then we have a function. All right, that one's a function. If, on the other hand, we had something that looked like this, if we drew or imagined a vertical line going over this graph, here would be intersecting at 2 points, here and here. So this would, the one on the right would not be a function, and it would have failed because of the vertical line test, not a function. All right, so let's look at some examples. Determine whether each relation below is a function, then write the domain and range. So in letter A, what we want to look for is if we have any elements of the domain that are repeating. So we have 4, 8, 1, 6, and 4. Okay, so 4 is repeated. Now we have to see if the output for each 4 is the same or not. So we have 4 with a -1 and 4 with a +1. Okay, so what should be happening? What should we be thinking here if the 4 is paired with a different output? Or if the 4 is repeated and it has a different output? Well, we should be thinking that this is not a function. The 4 is repeated with a different output. And that violates the rules of function, where a function has to be paired, one input has to be paired with exactly one output. Here, 4 is paired with 2 different outputs, a -1 and a 1. All right, and then we can still do the domain and range. So the domain would be least to greatest 1, 4, 6, 8. The range would be -1. So here we have -1 in the range 2 times, but that does not matter if it's repeated in the range. It does not matter if an element of the range is repeating it. Again, it does not matter if we have a y repeating. All right, so we have -1, 6. Again, see here 6 repeating, but that does not matter if it's in the range. And then, oh, I should have had the +1 in front of the 6. Okay. All right, so this is not a function for letter A. Let's go to letter B. Here we go. Let's look. 3, -1, 0, -3, -2. There is no repeating x values. So right away, we can say for certain that this is going to be a function. All right. So this will be a function. Let's write that down. And the domain, we'll put it in order least to greatest, -3, -2, -1, 0, 3. The range, we do have some repeating numbers. We have 2, 4, -3, 4. So we have 2 4s, but again, it's in the range, so it doesn't matter. -2. So the range from least to greatest, -3, -2, 2, and 4. All right. Let's go to choice or letter C now and take a look. This time we have a graph, so we're going to be able to use the vertical line test. All right. So I'm going to draw a vertical line. I'm going to see if I can set this up so I can drag it. All right, does not appear possible. So, but we're going to imagine that we're moving this vertical line across. So if the vertical line keeps moving to the right, all right, here it only intersects once. It intersects at 2 different points on this vertical line at x equals -2. So right away, we know that this is not a function. All right, because it's already intersecting. We have one element of the domain, a -2, with 2 different outputs, one at 0 and one at -1. All right, we keep moving that vertical line though, passes through once. All right, passes through once, and then, it happens again. So it fails the vertical line test twice. Passes through 2 times at x equals 4. All right, but all that being said, we can still turn this into a set of domain and range. The domain is going to be -4, -2. We don't repeat that -2 just because it's repeating here. 0, 1, 2, and 4. The range will be the outputs. So the lowest point, we do a different color.
Well, hello.
Well,
Figured these out and then realized I didn't really want them. I
-4,
don't want them now. All right.
-3,
Wasty.
-1, 0. Okay, that was Miss Gray. She did not know she was being recorded. 1, 2, up to 3, and then 4. All right, and those are all the elements of the range. Very good. We're almost there, guys. Let's take a look at one more little test. Okay, relations and functions. We're going to determine if each box is a relation or a function. Right, R for relation or F for function. So what we're looking for is if each element of the domain has a single output in the range. So for this first example up here, we have 9 paired with 4, that's fine. 0 is paired with -8, and 0 is paired with -2. So if 0, an element of the domain, is paired with 2 different outputs, then it cannot be a function. So this would be a relation. Let's go to the next one. Here, we're pairing -7 with 2, -5 with 4, -3 with 8, -1 with 6, and 0 with 10. Each one of the domain has a single arrow going from it to an element of the range, so this would be a function. Ooh, okay, we can also look at it like a number 3 with x and y. So -4 is paired with -2, -2 is paired with -1, and 0, 0. So each one of these is from the x is paired with one unique y. So that would be a function. All right. Then here we have -1 paired with 2, and we also have -1 paired with 6. So -1 has 2 different outputs, which means it's not a function, so it's a relation. Why don't you guys go ahead and try working on the rest of these, and I will just go ahead and put down the answers so you can compare. Okay, so you might be wondering how I was able to do that so quickly, and all I did was I simply scanned to see, let's look at this one in the corner here. Let's see the view. Let's say it's number 10. Well, I look and see, are my x's repeating? Are there any repeats? Okay, there is a repeat with the -1. Then I look at the outputs. All right, 2 and -2. Those are different outputs, so it must be a relation. So in all, gents, a function is a relation. It's a special type of relation where each input has only one output or one unique output. A relation, in general, is a pairing of inputs and outputs, or x's with y's. So all relations are not functions, but all functions are relations. They are a special type of relation.